Okay, welcome everybody. My name is Randy Powell. This is going to be a bit of an advanced class in Vortex-based mathematics for those of you who are familiar with Marco Rodin's work. If you're not familiar, you should go and look up Marco's videos, study a little bit on his work. I'm also going to be having classes going up online that will start from much simpler and explain in much more detail how the math works. This is really intended to be for Marco, for more advanced students, people who are studying in the math. I've made a discovery that I believe completely revolutionizes and changes vortex-based mathematics, will change the designs of technologies based on vortex-based mathematics, and I'm actually claiming to have taken this math to a completely different level, which reveals what a true whole number fractal is and how to determine exactly its composition. So I'm just going to start from the beginning. You can see I have my symbol here. Those of you who are familiar with the work have seen the symbol. It's called the symbol of enlightenment. This is the petroglyph for the equation for the most great name of God from the Baha'i faith, Abha. Okay, I'm just going to do a quick, super fast run through of how it works. And those of you who aren't familiar, go check out the other videos as well. Okay, so we start with 9 at the top. We have a circle. 1, 2, 3, 4, 5, 6, 7, 8, 9. The 9, of course, never changes. No matter what you multiply 9 by, it always reduces back to equal the number 9. All numbers, as we do functions on this, are going to reduce back to single digits. Why? Because we're looking at the underlying pattern. Okay, so let's look at the first pattern we have. We know it's doubling. If I follow this pathway, 1 doubled is 2, 2 doubled 4, 4 doubled is 8, 8 doubled is 16, but 6 and 1 is 7, 16 doubled is 32, 33 plus 2 is 5, 32 doubled is 64, which comes back to 10, 1, 128, which equals back to 2, 256, 512. You can go on and on forever. It will always keep doubling. Most of you are familiar with that. You can half the other way. Half of 1 is 0.5. Half of 0.5 is 0.25. 2 and 5 is 7. Half of 0.25 is 0.125, which is 8. 0.0625, which is 4. On and on. You can half forever. So we have both doubling and halving. This is actually the way we're going to learn to measure things in the physical world. They always come in these groups of 6. Okay? Really based on 3, but we won't go into that. Then we have our 9, 3, and 6. We're familiar with this. 3 doubled is 6, 6 doubled is 12, which is 3, 12 doubled is 24, which is back to 6, 24 doubled is 48, back to 3. They are oscillating. The 9 never changes. It forms an axis, which polarizes all these numbers. Okay? You can look this up on Marco's video. Other thing we want to, what I'm doing here, just to explain, is accounting for everything that has to be present on a true torus. Okay, so when we start modeling a torus with this, I'm giving you all the principles. So first thing is we have to have unbroken multiplication tables. Okay, we have to have doubling. We have to have the halving. Okay, we have to have the 3, 9, and 6 gap space in between. Next thing we have to have is family number groups. Okay, those are explained in the videos too. They're separated by thirds. 1 plus 3 is 4. 4 plus 3 is 7. 7 plus 3 is 10, which is back to 1. 10 plus 3 is 13, which is 4. 13 plus 3 is 16, which is 7. No matter how you do it, always 3 moving forwards. When you go backwards, 1 plus 6 is 7. 7 plus 6 is 13, which is 4. 13 plus 6 is 19, which is back to 1. 6 going backwards. 3 is representing forward motion. 6 backward motion. So we're going to see this on all levels of the torus. Same thing for 2, 5, and 8. Going 3 forward, 6 going backwards. Okay? And our third group, 3, 9, and 6, also separated in thirds like that. So you have to have these principles going on. The doubling and halving, the lining up of these pairs, your family number groups, all of those are going to be existent in the symbol. And all doubling circuits must begin and end at the same place. Okay? We have to be able to produce these circuits so they line up in order to create a shear along the torus. So those of you who have been working on that are familiar with that. Just an example of a shear, it's made out of reciprocals on this symbol. So I could use 1 as a control because this symbol is just using 1 as my control. 1 times 1 is 1. If I move in 1 on each line, 2 times 5 is 10 is 1. 4 times 7 is 28, which is 10, which is 1. 8 times 8 is 64, which comes back to 1. Okay, I can really use any number as a control on that and do the same thing, but that's one example of what I'm going to show on the actual torus as a shear. So again, if you've been working on this, you should be pretty familiar with that. So I just wanted to review that really fast, which I did, and now I'm going to move to my next piece. So after you've seen and become familiar with those symbols, you know that they turn into something else, which is this. Okay? It's called a torus. This is just one example. It's a hand-done approximation of what this should be, but nevertheless, I get the numbers filled in. So how did I make this? I'm using my multiplication tables. Okay? So we know multiples of 1, I'm going to be going up. 1, 2, 3, 4. Okay? It's very difficult to see here, but if you look at your own toroids, you know. I've got multiples of 8 going in the opposite direction, in towards the center. Here I've got multiples of 4 going around like this. 4, 8, 12, which is 3, 16, which is 7, 20. Okay, multiples of 5 going the other way. So multiples of 1 and 8 are my vertical axis on this particular toroid. Multiples of 4 and 5 are my horizontal axis. They make unbroken rings. We can use any multiple of 9. The example I'm using now is based on 36 on the horizontal and 18 on the vertical. Okay? And I'll explain that further as to how that makes pattern. Alright, but we just want to know that, and then I have my 2's and 7's coming through as my z-axis, which is invisible, though it can be observed on the skin of the torus by how it's displacing other numbers, but I won't go into that. What I want to explain is how these numbers, what has yet to have been understood, to my knowledge, is how these numbers create what are called nested vortices, which occur over the surface of the torus. They're explained to be just like dimples on a golf ball. They're supposed to increase the acceleration of the electricity as it moves through the coil. And they're also creating another phenomena spiraling over the surface of the coil, which is called spires. That's been one of the biggest subjects which has not been understood within vortex-based mathematics. So my goal is to explain it to you right now. What is a spire? How do they actually sequence? Okay, so that's the standard toroid. I'll show you just another example so you can see if you didn't catch it there. These look like squares. Of course, they should be diamonds. Really, it should be angled more like this. But you can see here my multiples of 1, 1, 2, 3, 4, 5, 6. And then I've got multiples of 8. Here, 8, 16, which is 7, 24, which is 6, 32, which is 5. So they're running in opposite directions. I have my multiples of 5, 5, 10, which is 1, 15, which is 6, 20. Okay, multiples of 4 going in the other way. And then my 2's and 7's are penetrating through the skin, coming out this way. Okay? Alright, so that makes my basic torus skin, which forms into a torus. Now, big question has been, how do we know what's a true torus? How many numbers do we need? Can we use 9 by 9? Can we use 18 by 18? Can we use any number? 27? Is there some number that's a true torus? Okay? No one has ever determined that until now. Okay? The standard approach to teaching the torus is more like this. See, I don't have the model for that. So the standard way of showing the winding of the coil is, it's said, or the winding of the doubling circuits along the torus, is said that it's one winding that comes all the way around many times until it meets back to where it started. So if I started right here, the idea would be, in the current teaching, it's not what I'm teaching, then the current teaching would be that the winding went in here, that you would skip, that it would come out here next, okay? Then it would come here, then here, then here, and here, and here. So, and then eventually it comes back around. So I may have miscounted, but it comes back around. Basically, you're skipping between each one, 1, 2, 3, 4, and this is where your next one is. Okay, those of you who are familiar with the illustrations of the winding of the coil will know that's how it's said it's being wound. I'm now stating that that is false, that that is not the path of the doubling circuits, no matter what number group torus you use. Okay, so now I'm going to explain to you what's the true path of the doubling circuits and what is actually being modeled by the winding of the coil. Let me show you it in just another way before I do that. Here you see another board. This is the standard winding for the Rodin coil. Okay, so I'll be following my 1 from here. I go to here, to here. Notice on my third one, I'm at a right angle from the first one. And I'm going to go here, here, here. Again, I'm at a right angle from that last one. 1, 2, 3, right angle from the last one. 1, 2, 3. I'm sorry, I should go 1, 2, 3. Now I'm back where I started. Okay, the other winding's going to work the same way, just in a mirror image. Okay, so it's going in a star shape all the way back around before it meets where it began. I'm stating that that is not the pathway of the doubling circuits on the quantized numerical torus. What this is actually modeling are spires, which are a completely different phenomena, and which cannot be accurately modeled by this winding of the coil. Okay, so let me go on to the next thing, which is what is the accurate model. Now again, I'm just going to use as an example a 36 by 18 torus. Okay, a 36 by 18 torus. I'm going to say now, and then when I finish explaining the 36 by 18, I'm going to just tell you the numbers on any given torus, so you can't just say that a 36 by 18 is not a valid torus. I'm saying that it is a valid torus, and that I can give you other examples. So instead of saying that the winding is going in here and then coming back around here and then winding many times, what I found is that they're actually, on a 36 by 18 coil, there are actually 6 different nested vortice pathways, which means 12 circuits. So whereas the other coil I was showing is 2 circuits, I'm saying it's really 12 circuits. And it's the interrelation of these circuits that makes the spires sequence, okay, and which will make the coil far more efficient. So here the pathway I'm showing you is actually the doubling circuits coming in this way, and they're coming back out here, directly across, back in, and then back around, so that this is an unbroken loop. Again, not breaking the initial principle of my symbol. The doubling circuits never break, okay? So it's an unbroken loop. Here's one directly opposed to it. So all in all, I'm going to have 6 groups, okay? 2 groups, each representing 3, I'm sorry, am I saying that right? 12 groups is what I should say. No, I should say 6 groups is the right, I'm sorry, forgive me. I'm thinking of many different number toruses. So 6 groups on this torus, and I'm going to show that in a much better illustration and show you exactly how to calculate it so it's perfect. I'm also opening this up because I want people to critique the work, try and approach it and attack it from every angle, and see if you can prove whether or not I'm right or wrong. I know I've already done the work on paper. Okay? So when you do that sequence in that way, what you get is this. Now, you can see each of these is 9 tiles that I've squared off. That represents one nested vortice. That's one vortice pathway over the surface of the torus. Okay, so if you don't know what a nested vortice is, you're going to be pretty lost in everything else I'm saying. So you should learn what a nested vortice is. Here I'm showing an image, though I don't have the polarities written in. I'm going to show another one where I do, of the nested vortice sequences. This was originally a sequence that Marco determined, though it could not be explained by the winding pattern that is being used for the coils. Because there would not be able to be unbroken circuits. These circuits would have to change from a red one to a green one to a blue one each time they went through if the winding pattern was what it's been said to be. If the winding pattern is like I have it, you have unbroken sequences where all the vortices connect in a line. And I actually found what the spires are. Let me show you what a spire is so you're not confused what I mean. Here's one image of spires. These are spirals going over the surface of the doubling circuits. So as the doubling circuits are going through and around, you can see the model I'm using for the doubling circuits forming really an actual image of the yin-yang, just like that. Okay? Over top of those spirals are other spirals. Okay? These are the spirals from what we're calling spires that you see in sequences such as the Fibonacci and the logarithmic spiral. Okay, so what is this circuit sequence? How do you give nested vortices numbers? And why is that significant for the Rodin coil? Okay? Because if you're winding the coil around in a star shape like that, you're actually cutting across the doubling circuits. You're not allowing these nested vortices to invert and make their own pathways. All right? So this is how it works. I found that what the spires actually are, let me see if I got my markers, I do. The spires are actually doubling circuits going over the surface of the toroid, and that have to do with the activation of each different family number group. So what I'm saying, here's first your regular torus, okay? Regular 1/8 northern view of a 1/8 torus, okay? And that's just with the numbers filled in. Now, if I circle the nested vortices, I know the regular numbers aren't filled in here, but now I'm going to give a number to each vortice. Well, how do I do that? First of all, I'll point out to you, if you're studying this, notice, if you go to the equator of your torus and you line up the multiples of 4 or 5 with any of these vortices, in other words, if you take a 4 that's, say, right here, it will be lined up with the vortice on that vertical axis. There'll be a 4 here and there'll be a 4 on the other side, mirroring it. So that all your vortices, in other words, when I have this one, I've got a 9 here. There's going to be a 9 on this adjacent circuit on the inside, perfectly mirroring this 9. All the way as they wrap around, all the vortices are perfectly mirroring each other. So if I line up, say I've got a 9 on this vertical axis, if I was to go over one space, I know there should be a 4 lining up with this one. And if I go all the way down, let's see, this should be actually, no, it should be 5. If I go over one, it should be a 5 lining up, and that's what I have. If I go over one more, it should be a 1 lining up, because this is going to be my multiples of 5. 5, 10, here's my 1. The next one over should line up with a 6, which it does right here. Okay, so I'm actually showing staggered multiples of 5 which form doubling circuits all the way around. Okay, so there's a doubling circuit coming in here, coming out and in here, back around like this, and there's 2 of them opposing each other which are of the same family number groups. So in this 36 by 18 torus, 2 of these circuits, what I'm calling a nested vortice circuit, so they're not the regular doubling circuits, but coming from the interaction of the regular doubling circuits in the gap space, you get a nested vortices circuit. There's two of these circuits operating at a given instant. And whereas it's been thought that the spires were really multiples of 1, in other words, I'd go multiples of 1 or 8, so I would have 8, here's a positive, I would have 7, 6, 5, 4, 3, 2. As I follow my spire around, I'll show you with the spiral on it. In other words, here's my positive 8. If I go to the next positive, it's 7. If I go to the next positive, it's 6. If I go to the next positive, it's 5. If I look at the negatives, I've got 8, 7, 6, 5. Okay? So it was thought that the spires were really just showing multiples of 1 and 8. What I found is that they're doing something completely, well, they are showing multiples of 1 and 8, but what I found is actually, I think, a more significant relationship. And that is between each family number group that I have in each given color. So I've got reds, I've got greens, I've got blues. They're creating a doubling circuit that's wrapping all the way around. So in other words, if I started with my 9 here, if I go follow the spire to my next red one, it's going to be 6. Now I know the next red one I connect with is going to be a 6 too, which it is, 6. Now I know the next one I reach is going to be 9. 9. Okay, next one's going to be 3. 3. Okay, next one's going to be 6. But you won't see it here, but it would align exactly with the 6. And it's going to end up wrapping around and crossing over in multiple spires that are really doubling circuits, traveling all the way over the surface. I'll show you another example. Here I'll start with an 8. We know our doubling circuits, 1, 2, 4, 8, 7, 5. So here I'm starting with an 8 just so it's easier to count. Okay, 8, go to my next blue, following the spire. 7, next blue. 5, okay, next blue. 1, next blue. 2. So in other words, there's another doubling circuit going all the way over. These are interlaced doubling circuits that have a sequence. They're firing in a trinary sequence, and they're creating a doubling circuit spiraling over the doubling circuits. I can not only show this pattern in the nested vortices, but I can also show it on the surface skin of the torus itself. Let me show you by doing it myself so you know I'm not just fudging it. Okay, so I'm going to make the same pattern that I had here. Notice here that these are mirrors of each other, that they show up the same, and always I have the same numbers in quadrature. So I have a 5, a 5, a 5, a 5, a 1, a 1, a 1, a 1. So these number sequences, the doubling sequences that are overlaid over top of each other, are all spiraling into the center. This is how you create an electrical venturi. It comes from multiple circuits allowing these nested vortices to sequence. If you just have one wrap going all the way around, you're just going to have one long sequence of vortices. The numbers will never align, and you'll never have a sequence. Let me show you. I've started here with a 9. We're going to call this one a positive 9. Okay? Positive 9 right there. Now, I'm just going to follow the pathway of my spire, which anybody, you just have to do the work yourself to find it, but you can put this work to the test. Okay? So I'm going to follow to where my next 396 family number group. I know I'm going to have to go over 3. 1, 2, 3. So that was a 9. Now I know this is going to be a 6. Okay, and it's going to be a negative 6. Okay, because I'm creating a doubling circuit. So with my 396 number group, the pattern is 396, 693, 396, 693. So I got 9, 6. 1, 2. This is going to be a 6 as well. I'll write it upside down. This one's going to be a positive 6. So I'm going positive, negative, positive. Okay? So 9, 6, 6. This is going to be a 9. Now it's going to be a negative 9. And I'm going to go 3, positive 3. Okay, and here I'm going to be off the page. Alright, so you can see anyway along one spire I've made a doubling circuit. Now does it connect? Well, let's see. We know that from either judging by our multiples of 5 along the circuit, which I'm just saying anytime you see multiples of 5 or multiples of 1 or multiples of any number, all it's really showing you is interlaced doubling circuits. So I know if I've got a positive 9 here, I'm going to have a positive 9 here. I can know that by counting the nested vortices. For instance, I have a positive 9 here. I know if I go over, let's see, if I go over 1, I'm going to go 1, 2, 3. That's going to align, no, I'm sorry, I should go 1, 2, 3. Where am I? Let's see, okay. 1, 2, 3. Yes, that's aligning over my next positive vortice. So I can count by going 1, 2, 3. I know it's going to be aligned over the next one here. Go 1, 2, 3. It's going to be aligned. So I can count the nested vortices and know exactly what number is going to come out on the other side, as long as I know how many increments are on my horizontal and vertical. Again, we're working with 36 and 18 here. I'll talk you through how all the sequences go. So I know there's a positive 9 here. Let's continue with my doubling circuit. So I know if I go 1, 2, this is going to be a negative 6. Okay? 1, 2, positive 6. 1, 2, negative, I'm sorry, where am I? 9, 6, 6, negative 9. 9, 1, 2, and then this is going to be 3, positive. Okay? And then that's going to keep going around. So again, I know if I go 180 degrees, it's going to be the same number. This is what you're actually seeing when you look at these spires, as in the winding of the coil. So I can do it from here. 9, 1, 2, negative 6. Notice it's not breaking my pattern. 1, 2, positive 6. Still not breaking my pattern. 1, 2, negative 9, which is not breaking my pattern. 1, 2, positive 3. Okay, so now I can see that there's this interlaced doubling circuit. All right, let's try another one, and then I'm just going to fill these in because this will take a long time if we do it, one by one. So I've got my positive 9 here. So I know now this is going to be my positive 8. How do I know that? Well, I know I'm going to have multiples of 1 this way, or multiples of 8. I also can tell, again, by checking the horizontal equator line. If I have a 9 here, I should count over, there should be an 8 directly lined up vertically with this 8, and there should be an 8 nested vortice on the underside of this, mirroring this one. And it's going to be on this circuit right here. As it comes through under here, it's going to mirror that 8. Okay, so let's try it with 8. So I got positive 8. I know I'm going to have, let's see, 1, 2. This is going to be negative, let's see, 7. Yep. And then I'm going to go 1, 2, positive 5. Okay, 1, 2, 3. Negative 1. 1, 2, and positive 2. Okay? So I ended up here on the 2. Let's try to fill this in. Now I got 2. I'm going to go 4. No, I'm sorry. This should be a 1. 2, 1, 5, 7, 8, 4. Notice here I still got 6, 7, 6, 5. My multiples of 1 aren't breaking. I know this is going to be a 4 now because I got 6, 5, 4, 3. So I can go ahead and fill these in. And I still got my doubling circuit. So let me show you how they work. Let me just fill it in. 5, 6, 7, 8, 9. See, that was already there. It didn't never break there. I know it's going to be 9, 6, 6, 9, 3. Let's see, 9, 1. This is going to be a negative 2, 4, 8, 7, 5. 1. Okay? I'm just filling in my doubling circuits. You can see now already that there's never any break. Let's try another doubling circuit. Let's see, I know here I'm going to have a negative 8. So here's my negative 5. Okay? I'm going to count 1, 2, positive 7. 1, 2. So this is going to be a negative 8. 1, 2. This is going to be a positive 4. 1, 2. Negative 2 is already there. Okay? So you can see clearly, I hope, that I'm making doubling circuits around this. Let's just fill the rest in. 8, 7, 6, 5, 4, 3, 5, 6, 7, 8, 9, 1, 2, 6, 5, 4, sorry I'm writing upside down, 3, 2, and I could still fill in my doubling circuit here. I've got 2, 1, 5, 7, 8, 4, okay? It always works any way that you do it, okay? So what I'm showing here now is that spires are not what they're really modeling, just like everything else, are overlapping doubling circuits. Or I shouldn't say overlapping, but interconnected doubling circuits. So let me show you again on this torus where it might be easier to see. Here's my positive 8. Next blue one following that line, negative 7, positive 5, negative 1, okay, positive 2. Let's try another one. Let's say here's a positive 5, okay, negative 1, positive 2. Let's go the other way. So we got positive 5, so it should be a negative 7. That's exactly what it is. Negative 7. Positive 8. Okay? Interlaced doubling circuits. So I challenge and promise everyone, go and try it on your own. That's what's going on here. What we need for these coils, if the quantized numerical torus is correct, are multiple circuits, all firing in a sequence, okay, which I can't explain, though it's too complicated for right here. We want to get it on 3D visuals. I'm inviting people who are working on the coils. If you want to work with me, you can contact me. I would like to try and develop designs, more designs, I already have some, based on this modeling. So now I'm going to show you, I'll show you some other ways you can approach it, just so you can see one way you can do this is on a flat piece of paper, just like I did the old-fashioned way by hand. It'll take you a little while. Each of these quadrants that I'm showing here, this would be 1, 2, 3, 4, 5, 6. Each of those quadrants is a 9 by 9. Okay? I'm claiming that that's the smallest possible torus you can make, a 9 by 9. By linking those smaller toruses together, you can make larger groups, and there's a pattern to how the circuits change. But no matter how many circuits you have, no matter how many doubling patterns you have, they always connect back to themselves. They're always unbroken. You always have unbroken multiplication tables, and your nested vortices sequences never change. I don't ever have to move a number. I can just add more and more in, and the pattern always works. The other thing is, no matter what combination of numbers, I always have unbroken doubling circuit spires all the way around the torus, and it's one sequence that comes in, comes back out, around many, many times, depending on how many numbers you have here. Here's another sheet. This is showing where I filled in the nested vortices sequence numbers. If you look closely at this, or if you do it yourself, you'll find that it's the same number pattern in every single quadrant. Doesn't matter. You can keep adding, I shouldn't really call them quadrants, but I don't know what else to call them, squares. you can keep adding squares in, and you never have to move any numbers. So I could draw this square, fill in its numbers, and I could add one over here, same numbers, never breaks here. So it never alters the sequence, and you always have spires connecting. You can work it out on your own, find out for yourself. Just to take it a step further so that you know I do my homework, I did it in a higher base system for those of you who worked in the really complicated stuff of this. And I'm about to read you off the numbers for these. This is base 26. Okay? It's the next step up from a base 10 or modular 9. This is base 26. This is what the torus skin looks like for a base 26. There's actually 4 circuits instead of 2 and 1 gap space. Okay? They're mirror imaging each other. They also have a sequence to their vortices and how they work. I've written out that sequence, and I can now prove and show what that sequence is. Still not one interconnected circuit. It's multiple interlaced circuits depending on how many of these squares. So whereas I showed you one square is a 9 by 9, this is one square of a 25 by 25. Okay? So let me now read to you the numbers. If I haven't lost everybody already, I'm just trying to get this out there so that people, if you want, you can contact me on it. I'm not kidding about the work that I'm saying. This completely changes the picture of vortex-based mathematics. One thing I should show you before I read out the numbers, I never did say, in that case, the original winding pattern, this star shape that goes all around, well, what is it modeling? Well, I'll show you. When you're talking about a 1, or let's start with an 8. We're just doing family number groups, so it doesn't matter. This 8, whereas the winding sequence would carry it down, what is it really modeling? Okay, so here I go 8, 6, 7, 7. Here's my 5. Okay, the 8's connecting to this 5 on the same blue spiral, and then it's this 2 here. So the pattern of the spires is actually going here, here in family number groups. Then I go to my next 8, which is 180 degrees across. So in other words, by the sequencing of the nested vortices, I am preserving the same pattern of the original winding of the coil. The difference is, whereas this coil is being wound really what I consider in a two-dimensional fashion, it's flat, in other words. Even though it's winding around a donut, it's not actually winding correctly, because when in my winding pattern, instead of having a straight line coming here, mine would curve around, crossing these other numbers, but the family number groups aren't all the same distance from the center. Just like in our symbol where we've got 1 out here, 1 in the middle, and 1 close to the inside, when you model them according to spires, that's exactly what you have too. 1 out here on the outside, 1 in the middle, and 1 on the inside. All triangulated in the same pattern. So with my winding pattern, I wouldn't come straight up over the surface of the torus in order to shoot back at another angle. I would have a much more gradual curve that connected to this number down towards the base, down here on the same doubling circuit. Then when it gets to this number, it's up here, so that I preserve this S-curve along the winding of the coil. This is super important. It's not being done right now with the current winding. This S-curve is not preserved. So my winding would come around at an angle, it would cross here, come back around, again, crossing the family number groups, but at different distances from the center, going inside, back around, and connecting right at 180 degrees across. Okay? I hope you followed me on that. All right, let me read you out, just to round some of this off. You can contact me, by the way, my email, which is tricky, T-R-I-C-K-Y, _ gnosis, G-N-O-S-I-S, at yahoo.com. You can write me. I'm willing to work with people on building coils. I'm making a large claim about this. I'm inviting everyone to dissect my work. Okay? And I'll be the first one happy at the pie eating ceremony if proven wrong. The other claim I'm making is that either my work is correct, the quantized numerical torus is correct, and the technology needs to be reconfigured, rewound design, or we have to redefine what we're talking about with vortex-based mathematics, because if my winding pattern is incorrect, it means that doubling circuits aren't circuits at all, and that we're modeling, what we're modeling as circuits are really spires, which are going over the surface of the doubling circuits. Two different things. I believe that modeling your circuits by spires doesn't allow the nested vortices to occur, or to occur at their maximum potential. Okay? All right, here are, and you can write these down. I don't have time to write them all down and post them right now, but I'll read them slowly so that you can follow me. Okay, so when I give the numbers here, if I say 9 by 9 or 18 by 18, I'm starting with even groups. So in other words, it's either going to be 9 by 9, 18 by 18, 27 by 27, 36 by 36. Okay, this one I said was 36 by 18, but I'll show you that in a minute. So first with even groups. On a 9 by 9 torus, I'm saying you'll have three, what I call, and I'm defining now as a nested vortices circuit. That's one of these nested vortices family number groups that curves in here, comes out directly across and back in the other side in a perfect mirror. Okay? It's also, by the way, mirroring the number group, which is 3 behind it, directly at 90 degrees across. They're forming helical curved mirrors. Okay, so on a 9 by 9, you're going to have three nested vortices circuits. This is the minimum that you can have in the system. So it's never one interconnected circuit. So you have three nested vortices circuits, which means you have 6 doubling circuits. That consists of 18 vortices, so it's 3 groups of 6 vortices. On an 18 by 18 torus, we have 6 nested vortices circuits, okay, which gives me 12 regular doubling circuits, 72 vortices, 6 groups of 12 vortices each. On a 27 by 27 torus, we have 9 nested vortices circuits. So notice as I go up, it's just going 3, 6, 9. Okay? I have 18 doubling circuits, 162 vortices, and they're in 9 groups of 18 vortices each. On a 36 by 36 torus, I have 12 nested vortices circuits. I went 3, 6, 9, 12. I have 288 vortices, 24 circuits. They're in 12 groups of 24. So notice these are going up in clear multiples. You can write them down and look at it. They're multiples of 3, multiples of 6. They're going to be multiples of 12. Okay? 45 by 45. I have 15 nested vortices circuits, 450 vortices. There's 30 doubling circuits. The vortices are in 15 groups of 30. 54 by 54, 18 nested vortices circuits. That makes 36 doubling circuits. 648 vortices, 18 groups of 36. 63 by 63s, 21 nested vortices circuits, 882 vortices, 42 doubling circuits, and they're in 21 groups of 42 vortices. I have this going all the way up to 108. I can keep going. I'm not going to read them all. You can do the work on your own and find out. You're just going to find the same thing that I found. Let's try with a different ratio. Instead of doing even numbers, 9 by 9, 18 by 18, now we're going to do a ratio of half. So I'm going to have half on the vertical as I do on the horizontal, or you really could do it the other way. The vortices still add up the same. But we'll say half on the vertical as the horizontal. So I'm going to start with 9 on my vertical and 18 on my horizontal. For that torus, I have 3 nested vortices circuits, 36 vortices. They're in 3 groups of 12, and they have 6 doubling circuits. For an 18 by 36, that's what this torus was based on. I have 6 nested vortices circuits, just like I showed you. 144 vortices, 12 doubling circuits. They're in 6 groups of 24. In a 27 by 54, I have 9 nested vortices circuits, 324 vortices, 18 doubling circuits. There are 9 groups of 36. For a 36 by 72 torus, I have 12 nested vortices circuits, 576 vortices, 24 doubling circuits. They're in 12 groups of 48. Again, I've taken this all the way up, 63 by 126. The formula never breaks. Just to satisfy you, I'm going to do a couple more, and then we'll see where this goes. I did a ratio of 1/3 just to test it as well. So now I'm talking about 9 by 27, 18 by 54, 27 by 81. Okay, I hope you can follow me. So 9 by 27, I have 3 nested vortices circuits, 6 doubling circuits. 81 torus, I have 9 nested vortices circuits, 486 vortices. They're in 9 groups of 54, and that's 18 doubling circuits. So again, I've taken this up higher and higher. As far as the other base system, I'm sure that no one is really up to speed too much on that. The circuits still work, basically, the way they add up. If I do a 25 by 25, I have 50 vortices. They're in 5 groups of 10. That's because here I'm working with a different base system where I'm working with groups of 5 instead of groups of 3. All right, so these are 5 groups of 10. If I do a 50 by 50, I've got 200 vortices, and they're in 10 groups of 20, still based on multiples of 5. Okay, this whole system is based on multiples of 5. It's the 5 squared. 75 by 75's got 450 vortices. They're in 15 groups of 30. 100 by 100, there are 800 vortices. They're in 20 groups of 40. Scale it as far as you want. You're going to find the same result. So, with all that said, it's very difficult to explain in such a rapid explanation. My goal is to have this work dissected. I'm claiming a huge claim, which is that all of the current applications and tests are fatally flawed because of this. And if that is not the case, then the whole mathematical system has a huge challenge in front of it, which is that it needs to be completely redefined. So I'm saying it's got to be one or the other. I'm putting myself out there to make that claim, and I'm claiming that now I have discovered a whole new realm in vortex-based mathematics and 3D fractals, and this is just the beginning of what I'm working on. So with that, I'll leave it there. I appreciate your time and patience and listening. Please write me in too. Let me know questions that you have. Do the work out on a sheet of paper. Try it on your different toruses. I'm saying I have perfect mirrors in every possible angle you can attack it from. I have absolute perfection on the torus. I have perfection of nested vortices sequence. I have perfection of my doubling circuits. I have perfection of the multiplication tables. Okay? I have abided by every single principle that's in the original symbol without breaking one. And I am claiming that if there are not multiple circuits, then there is no nested vortice sequencing. And in that case, this whole thing needs to be trashed. I don't believe that. I believe it's true and valid. That's why I believe it's important to understand this multiple circuits. If you want to make this thing fly, this is how you steer it. This is how you control it, by controlling these nested vortices. I'm now saying I have the secret to it. So I humbly submit that to peer review, and I hope you guys have enjoyed what you've seen. Thank you.